I want you to do something for me right now. It's just a little mental exercise.
Okay.
Picture yourself walking into your kitchen. You walk over to that one cupboard. You know, the one, it's probably a bit of a disorganized mess of jars and packets. And you just stare at your spice rack.
Oh, yeah. That is usually the most chaotic real estate in the entire house.
It really is. So you reach in and you grab a jar. Let's say it's oregano for a pizza night. Or maybe it's that tiny, incredibly expensive vial of saffron you bought for a paella 3 years ago.
And haven't touched since.
Exactly. Now look at that powder. And I want you to ask yourself a question that feels, I don't know, a little paranoid, but it's actually statistically very reasonable. Is that actually oregano? Is that actually saffron?
And that's a question we almost never ask, isn't it? We just trust the label. If it says cinnamon, we assume it's cinnamon.
We do. But today, well, we're going to dismantle that trust. We're taking a whole stack of reports data from the FDA, the European Safety Authority, technical papers from industry heavyweights like Merieux NutriSciences, and we are unpacking a topic that, honestly, it sounds like a conspiracy theory.
But it's really just cold, hard global economics. We are talking about food fraud.
Specifically, the invisible crime wave happening in the spice aisle.
Right.
And just to set the stakes here immediately, we aren't talking about a farmer accidentally letting a few blades of grass get into the harvest. This is a massive, organized economic issue.
A huge one.
The FDA data we have suggests that food fraud costs the global food industry somewhere between, 10 and $15 billion annually?
Billion, with a B.
That is just a staggering amount of money.
It is. And to put that in perspective for you, estimates suggest that food fraud affects about 1% of the global food industry. Now, 1% might sound like, a rounding error.
Sure, it sounds tiny.
But you have to think about the scale. You apply 1% to the total caloric intake of 8 billion people, and the sheer tonnage of compromised food moving around the planet is, it's colossal.
So our mission for this deep dive is to figure out the how and the why. How do you fake a spice so convincingly that it fools chefs and buyers? Why did we see such a massive spike in this recently?
And then the really cool part.
And then, we are going to get into the CSI side of things because the science used to catch these guys is absolutely mind-blowing. We're talking DNA, metabarcoding, magnetic resonance, the works.
It's really become a technological arms race. On one side, you have fraudsters using these, increasingly sophisticated chemical tricks. On the other, you have scientists using tools that wouldn't look out of place in a biomedical research lab or a crime lab.
Okay, so let's start with the crime itself. Why spices? If I'm a criminal mastermind looking to make a quick buck, why am I targeting pepper and paprika? Why not fake, pharmaceuticals or electronics?
Well, it really comes down to the intersection of two things. High value and high vulnerability.
Oh.
First, the value density. Spices, herbs, botanicals, they are expensive commodities. Saffron is, pound for pound, more expensive than gold in some markets.
Wow.
Even things like vanilla, cardamom, or high-grade pepper, they command a really significant price.
The profit margin is just baked right in. If you can dilute that expensive powder with something that costs pennies, you're essentially printing money.
Exactly. But the second factor, the vulnerability, that's where the perfect crime aspect comes in. And it's all about the processing.
The process.
Yeah. Think about the supply chain. A spice often starts with a smallholder farmer, goes to a local collector, then a processor, an exporter, an importer, and finally a packager.
That is a long chain of custody, a lot of handovers.
So many opportunities for a switch. But the real key is the physical transformation. Spices are dried, cleaned, crushed, and ground. And as soon as you grind something into a powder, you destroy what we call its morphological identity.
Morphological identity. That's a great term. So it basically loses the shape and structure that tells you what it is.
Precisely. If I hand you a whole nutmeg seed, you know exactly what it is. It's hard to fake a hard, wrinkled nutmeg seed.
Right.
But if I hand you a pile of brown dust, that could be nutmeg. It could be ground apricot kernels. It could be wood dust with a little synthetic scent added.
So once it's dust, visual inspection is useless.
Totally useless. And that invisibility is what allows the different types of fraud to happen. The reports break this down into a few categories: adulteration, substitution, dilution.
Okay, can you walk us through the difference there?
Sure. They all sound similar, but the intent and method are different. Adulteration is usually adding a foreign substance to bulk it up, like adding starch to a spice to increase its weight.
Right.
Substitution is the classic bait and switch, selling you dried strawberry leaves or olive leaves and calling it wild sage or oregano.
Which actually happens. People sell olive leaves as oregano.
Oh, absolutely. Or spent ingredients. This one is particularly clever and insidious. Imagine you're a ginger processor. You extract all the flavor oils and oleoresins from the ginger to sell to a soda company.
Right, so you've taken out all the good stuff.
All of it. You're left with this fibrous, tasteless ginger mash.
Which is essentially trash. It's just the skeleton of the ginger.
It should be waste. But instead, you dry it out, grind it up into a fine powder, and mix it back into fresh ginger powder.
No way.
It is ginger, genetically speaking, but it has zero flavor and zero value. That's dilution.
That is wild. Because you technically aren't lying about the species, just the quality. You're selling a hollow shell.
You got it. And then there's mislabeling, specifically about origin. Vietnamese cassia commands a higher price than generic cinnamon. If you just lie about the geography to charge a premium, that's fraud too.
And looking at the data, we saw a massive surge in all of this recently. The European Food Safety Authority flagged a 30% increase in food fraud incidents during the pandemic.
That really shouldn't surprise us, honestly, if you look at the macroeconomics of that period.
Everything was disrupted.
You had supply chain ruptures, you had commodity shortages, and you had record inflation. When the real product becomes hard to get and expensive to ship, the incentive to cheat just skyrockets. It was the perfect storm.
So who are the usual suspects? If I'm looking at my spice rack right now, which jars should I be eyeing with a little bit of suspicion?
Well, the European Commission did a massive survey on authenticity, and they put together a kind of dirty list.
Okay.
The spices most commonly found to be adulterated are oregano, pepper, cumin, curcuma, which is turmeric saffron, and chili powder.
Oregano's on there. That seems so humble. It's the pizza herb.
It is, but it's high volume. Everyone uses it.
Yeah.
And dried crushed olive leaves look remarkably like dried crushed oregano. Unless you have a very sensitive nose, you might not even notice if the ratio is, say, 50-50.
Okay, so we know it's happening. We know it's profitable. But I want to pivot a bit to why this matters beyond just, culinary disappointment. I noticed in the source material there was a mention of a brochure titled Lead Fraud in the Spice Supply Chain. And that word lead just stopped me in my tracks.
It should. This is where we cross the line from economic swindle to public health crisis.
Because fraudsters aren't exactly following FDA safety guidelines when they're mixing up their fake batches.
Exactly. If a fraudster is adding a filler, they aren't checking if that filler was grown with banned pesticides, but specifically with lead. Think about color. We eat with our eyes, right?
Of course.
We want our turmeric to be bright yellow and our paprika to be vibrant red.
So if you have old, dull paprika that's been sitting in a warehouse for 2 years, how do you fix it?
You use dyes. And historically, some of the cheapest, brightest, most stable industrial dyes like lead chromate are incredibly toxic. We have absolutely seen cases where lead chromate was added to turmeric to boost that golden color.
That's terrifying. You're essentially poisoning people to make a spice look fresher on the shelf.
And it brings us right back to why the CSI aspect, the high-tech detection, is so critical. We can't just taste test for lead. We can't taste test for pesticide residues on strawberry leaves that are masquerading as sage. We need hard chemistry.
So let's get into the lab. The source material talks about the chemistry of deception. If I'm a scientist at a place like Merieux NutriSciences, what's my first line of defense?
It starts with something called chemical profiling. You have to stop looking at the spice as food and start looking at it as a complex chemical data set. You're hunting for anomalies.
Give me an example of an anomaly. What does the machine see that I don't?
Okay, take that vibrant red paprika again. If you run it through a spectrophotometer, which measures how light interacts with the material, you might see an absorption peak on the graph that simply does not belong to natural peppers.
And that peak?
That peak matches the signature of a synthetic dye. Busted.
It's like finding a typo in a manuscript.
Or you use chromatography. Think of this as a molecular race. You dissolve the sample and push it through a column. Different molecules move at different speeds based on their size and properties.
Okay.
So if your pure cinnamon has a massive spike of a chemical compound that only exists in, say, coffee husks, you know it's been cut with coffee husks.
So they're comparing the sample against a master file, a known good sample.
Yes. They compare it against an authentic reference profile. If the graph doesn't match the master file, you've got a problem.
But what about the origin fraud? The Spanish saffron, that's actually from Iran. Chemically, saffron is saffron, right? A molecule is a molecule.
To a degree. But plants are what they eat. Or, rather, what they drink. And this is where isotopic analysis comes in.
This is the one that sounds like nuclear physics.
It sort of is. It deals with stable isotopes. The water and soil in Spain have a different ratio of hydrogen and oxygen isotopes compared to the water and soil in Iran.
Ah, I see.
When the plant grows, it locks that ratio right into its tissues.
So it's a geochemical signature. The plant has a passport stamped into its very atoms.
That is a perfect analogy. You can literally map the isotopes to a geographic region. You can't fake that in a processing plant. You can't just wash away the atomic signature of where you grew up.
That is incredibly cool. But, and here is where the tech gets really futuristic, sometimes chemistry isn't enough. If I'm dealing with a really complex biological mess, like a steak rub with 20 ingredients, I imagine chemical profiling gets noisy.
It does. It gets very noisy. If you have 20 plants in a jar, the chemical peaks all overlap. It's a mess. And that's when you have to stop looking at the molecules and start looking at the code.
The DNA.
The DNA.
This is the CSI pantry section. I was reading about the capabilities of Merieux NutriSciences, and they're using something called DNA metabarcoding. How is that different from the DNA tests we've had for, 20 years?
Well, the old school method was targeted. It was like using the find function in a Word document. You would ask the sample, is there horse meat in this? And the test would say yes or no.
But you had to know what to ask for.
Exactly. So if you didn't think to ask, is there almond shell in this? It wouldn't tell you. You could miss the contamination completely because you didn't suspect it.
Okay, so how is metabarcoding different?
Metabarcoding, which is empowered by next-generation sequencing, or NGS, is totally different. It doesn't ask a specific question. It takes the sample and it sequences everything in it simultaneously.
It reads the whole room.
It reads the whole room. It's designed for what we call complex matrices. That's the scientific term for your steak rub or your curry powder. It can look at that powder and give you a list. 40% pepper, 10% garlic, 5% onion. And wait a second. Why is there 20% olive leaf DNA in here?
So it finds the unknowns, the things you didn't even know to look for.
It unmasks the imposters, even if you didn't know they were there. It is a massive leap forward because it's untargeted. You don't need a hypothesis. You just need the sample.
And Merieux NutriSciences combines this with another technology that I usually associate with hospitals, NMR, nuclear magnetic resonance.
Yes. It is the exact same physics as an MRI machine.
So we are literally giving the human an MRI.
In a sense, yeah. An MRI uses strong magnetic fields to look at the water in your body to create an image. NMR, in food, looks at the magnetic properties of atomic nuclei to create a spectral fingerprint.
Why use this over the other methods? Why do we need the MRI if we already have the DNA?
Because it provides a holistic view. DNA tells you species. It'll tell you, this is basil, but DNA won't tell you if that basil was processed correctly or if it's been stored improperly and degraded.
I see.
NMR gives you a snapshot of the structure, composition, and the state of the molecules all at once.
So it captures the quality, not just the identity.
Exactly. It's incredibly robust for authenticity. And it sounds like overkill, but fraud is diverse, so the detection has to be multimodal. If you rely on just one test, the fraudsters will figure out how to beat that one test.
But if you come at them with DNA and isotopes and NMR,
they have nowhere to hide.
Which brings us to the other side of the shield. We have the detectives, the scientists, but what about the police, the regulations? Because all this tech is great, but someone has to enforce the rule.
This is where the landscape shifted, and shifted dramatically back in 2011 with FSMA, the Food Safety Modernization Act.
I know FSMA was a big deal, but usually people talk about it regarding bacteria, E. coli, salmonella, that kind of thing.
And that was the headline, for sure. But FSMA also introduced a critical concept called food defense.
Food defense? It sounds military.
It is a security mindset. Before FSMA, the industry focused on safety, which is preventing accidental contamination. Oops, we didn't wash the lettuce. Food defense is about preventing intentional adulteration.
So it forces companies to stop being reactive and start being proactive.
That's it. You have to assume someone is actively trying to cheat you or hurt your customers. You have to conduct vulnerability assessments.
So you have to look at your supply chain and ask, where's the weak point?
Where is the weak point? Is it the loading dock? Is it the mixing tank that isn't locked at night? Is it a disgruntled employee? And then you have to implement a mitigation plan.
So you can't just leave the warehouse door open anymore.
Exactly. It involves stringent access controls, employee training, and really verifying who is handling your product.
And speaking of verification, the industry is trying to modernize this too. I'm seeing mentions of blockchain and AI in the source material. Is that just buzzword salad, or is it actually doing something?
In this case, it has real utility. Blockchain is all about immutability. If you track a spice from the farm to the jar and every single handoff is recorded on a blockchain, you create a digital thread that is very, very hard to fake retrospectively.
So transparency is the weapon.
Transparency plus verification. You can have all the blockchain in the world, but if the data you put in is a lie...
Garbage in, garbage out.
Right. The blockchain just records the lie forever, and that is why you still need the third-party verification. Companies like Merieux NutriSciences don't just test the powder, they audit the suppliers. They check for SQF certification, GFSI standards. They act as the independent referee.
It prevents the grading your own homework problem.
Precisely. And the fact that Merieux is showcasing these solutions at the upcoming ASTIA 2026 conference, that's the American Spice Trade Association, it just shows that the industry is taking this seriously. They're gathering to strategize because the fraudsters aren't stopping.
It really is a war, isn't it? A constant cat-and-mouse game.
It is, and the fraudsters are adaptable. When we got good at detecting lead chromate, they switched to organic dyes that were harder to find. When we got good at DNA, they started using extraction methods that degrade DNA. It's a cycle.
So, for the listener who is now eyeing their chili powder with deep suspicion, what is the takeaway? Should we stop buying spices and just grow everything on our windowsill?
No, not at all. The takeaway is that the good guys are winning the technological battle. The safeguards today are light years ahead of where they were 10 years ago. The net is tightening.
It is comforting to know there are people looking at the molecular spin of my turmeric so I don't have to.
It is, but it also emphasizes the value of the brand. When you buy from a reputable brand, you aren't just paying for the nice logo. You are paying for that food defense plan. You're paying for the audits, the DNA testing, the traceability.
The cheap stuff is cheap for a reason.
Almost always. If a price seems too good to be true, like saffron that costs the same as parsley, it's probably because you are buying dyed corn silk or marigold petals.
Before we wrap up, I want to throw a bit of a curveball. We've talked about how advanced this detection is, DNA, isotopes, and NMR. We're detecting nature. But we're entering the age of synthetic biology.
We are. That is the next frontier.
We're seeing lab-grown meat, precision fermentation. We can program yeast to produce vanilla flavor that is chemically identical to the bean.
Yes, biovanillin produced by fermentation is already a huge industry.
So here's the question. As the fraudsters watch these same technologies, will we reach a point where the fake is so perfect, molecule for molecule, that even the NMR and the isotopes can't tell the difference?
That is the philosophical edge of food science. If you synthesize a nature-identical molecule in a lab, is it fraud to sell it as natural? Legally, yes. Chemically, it is getting much harder to say.
And if the flavor is perfect, and the safety is perfect, and the chemistry is perfect, does the consumer even care?
To the purist, yes. To the chemist, maybe not. But until we reach that sci-fi future where we can, print spices, we have to keep checking the DNA.
Something to chew on, literally, next time you season your dinner. Thanks for diving deep with us.
Always a pleasure.
Stay curious, everyone. We'll see you in the next deep dive.